So as a data analyst, it is not encouraging to always ask them each time they ask you a question. It takes extra processing for them to get that data set into the format that you require. So if you are skilled in SQL, what it does for you is it allows you to interact directly with the database. So say you are asked a question that would require, you ask a question, um, in the next 3 months, what is the likely income that we're expecting? Yes. Now you know the data set that you are needing. These people have very large data. Some of them, their tables can go as large as 200, 300, even up to 1,000 different tables containing data. So you know what you need. You know that for you, you need the income field and code. So with a skill in SQL, it allows you to interact directly with the database, get the data sets that you need from their database and analyze it. So you don't need to start waiting for somebody to get you data sets in Excel format or say CSV format before you can start operating. So that's why normally you see SQL is one of the most important tools. I was interacting on LinkedIn, and many persons, there was a question that how important is SQL to a data analyst, and many persons who were responding were like they use SQL the most in a data analyst role, because most times it is the speed at which you answer questions is important. So it is not encouraging for you to always wait on Excel. They ask you small question. How many customers do we have? Then you have to wait on Excel file to come before you can answer those questions. SQL, you can interact with the database directly, analyze from the database directly, even without getting the data set down. So such is the power of SQL. Now, another skill that is important is the Excel skill. Excel. Now, why do you need Excel? There are actually other tools there, other more flashy tools that you can use than Excel. But Excel is not likely to go out, to fizzle out anytime soon. That's because the people who are asking these questions, the people who want to see this data, they don't know SQL. Many of them don't know Power BI. So most times they still prefer to interact with Excel. So it is not likely that you are not going to work with Excel. You are still going to work with Excel. And for those persons who are not using database, probably who are having manual data, and most of their data will come in Excel format. Now, if you still need to make presentations, like you need to create charts, you need to create dashboard, many of these people still prefer to interact with Excel than the other visualization tools. So Excel is actually still important as for a data analyst. Are the things that you're going to do what are the things that you're going to use Excel for? Basically, I think for a data analyst, the major important part is to present your data. Yes, you have those large database. You want to present it in a form that is available, that the decision makers can easily interact with, and you can easily do those using Excel. Now, another important tool, either of them, Power BI or Tableau. I believe we must have had Power BI, Tableau. It was popular sometime around 2020. They blew up sometime around 2021, like that. It is not necessary that you actually have the two of them. It is or Power BI or Tableau, because they do almost the same thing. Now, the choice between the two of them will be dependent on you, actually. But the difference that I see in the both of them is that Tableau has final graphics. You're able to do cleaner dashboards with Tableau. Yes. Power BI doesn't have that much fine-grained control as Tableau. So the charts in Power BI doesn't look as clean as that of Tableau. But the problem with them is Tableau is not free. Power BI is free. So you are most likely going to use Power BI. most likely. But this shouldn't be a point of, it shouldn't take you, the decision shouldn't take you that much because they are similar tools. Yes, if you know Tableau, you can easily pick up Power BI. If your job role requires Power BI, it's easy for you to just to port to Power BI. But if I would advise, I would encourage you go you do Power BI because many persons would actually want to go with the freer thing than the more flashy. I wouldn't think anybody would want to spend extra cash to get those extra flashy designs there. So I would encourage Power BI instead, but it's actually your choice though. Now, what are the other tools that a data analyst might require? Python. I actually place this under other tools because it's an added skill for a data analyst. Actually. With the major tools, SQL, Excel, Power BI, I think someone should function properly in the data analyst field. But if you have knowledge of Python, that's extra. Now, what do you do with Python? Python allows you to automate. Yes, Python gives you final grain control of your data processing. With SQL, Excel, you can actually you can process your data. But if you now need to be processing those data every now and then, or each time new logic comes and they are not so different from, I think Python is way more easier to implement than trying to execute those in Excel. Although this is actually a preference. This is actually preference, though. There's a level of Excel that you reach and you can do those pre-processing and go in Power BI and Excel. But I feel that it is easier to implement using a tool like Python or R. Jupyter Notebook is actually one way of working with Python. It's a tool for working with Python actually. And Git is where you can save your code. There are additional tools for a data. Now, what are the background, the strengths that you have that will allow you to function well as a data analyst? Strengths, those strengths that you should have, those little traits. Are you the type that communicates, that have this communication skill? Because at the end of the day, it is not all about your chart. Nobody cares. That's the truth of it. If it's not driving business decision, if it's not pushing people to act, I don't think they care. Because while you are playing with it on your notebook, it's fun to you. It's fun. Yeah, you did X, you did Y, and you saw the chart play left and right. It's always fun to see those results. But the problem is, can you communicate them? Because when you go into the field, you might find yourself in that way where your chart is driving multi-million naira decisions. At that point, it's no longer fun. Yes, because if you get it wrong, or you are not able to present your points clearly, then you stand a risk of running a business now. It's not going to be fun at that point again. Yes. So, are you the type that have strong communication skills? If you don't have strong communication skills and you want to be a data analyst, I think it is time to look into that. You must know how to communicate your findings. Some persons wouldn't do half the work you did, but they are able to drive decisions because they can communicate their findings. Yeah, you have this, you've explored your data set, you know that this would work really well for the company. You know that they should focus their advert towards Maguro. If they focus their advert towards Maguro, they should be able to double their income. But how do you convince those making businesses that they should focus adverts to Maguro when there is other regions? How do you make them believe that you actually know what you are saying? So it's one of the functions of a data analyst. Another thing you want to consider is statistics. Well, I say if you have statistics background, if you have skill in statistics, it's an added advantage. Now, if you cannot learn it though, you can. But you should pay attention to statistics. Yes. Because at the end of the day, there are statistical terms that will allow you to communicate your findings. For an example, I was looking at a chart some time ago, And somebody was telling me that ladies who are given scholarship actually perform better than the men. It was a South African data set. I looked at it first time and I tend to agree. Almost towards when we are going to make presentation there, I looked at the data set again. Now that data set has about 15% female and about 85% male. In fact, the number of males who are successful are like ×4 of the number of females. But now when you plot the chart, because female are like, let's say if we have 90 females and 85 of them are successful, you know how the chart will look. Yes, we have 80 females, 75 of them are successful. When you plot that, you see it. Now it is now when you now plot it relatively that you see that compared to the men, it is still. Did you get the point there? So there are some statistical tools and techniques that will allow you to verify those claims. Yes, they allow you to test those claims. Okay, you have a claim now that this is actually happening. You want to present those claims. Whatever it is that you find is not necessarily does not mean that it is true as at that point. It might be something has skewed your data set. Well, you can't know. You see that it correlates. Correlation is not always causation, but there are statistical tools that will allow you to establish that that belief, that will allow you present your claims in concrete form. So statistics is one thing you want to look at. Now look at the data scientist landscape. This is actually trickish though. Yes. So what's the business? You hear data scientist, you hear data analyst. They are actually different. Now, why the data analyst primary role is in the business and data understanding landscape, a data scientist's role is actually a combination of business understanding, prediction, and automation. Now, when you choose to add predictions and automation to your roles, your primary function, then you are grown into a data scientist. I don't think so. I would still like to point us back the different ways people use data. Remember, we say they use it for business understanding, for data understanding, for prediction and automation. If you are a data scientist, you are expected to function in the 3 areas. A data analyst functions business understanding primarily. You are not expecting a data analyst to come and start making predictions. Well, they can make predictions from what they have before. Are we there? They can actually make predictions from what they have before, but the data set has to be in a form that will point towards those predictions. That they just make analysis and derive, like say, okay, from what I know before, I'll just conclude that this should happen in the future. But a data scientist is has that skill set to actually look more into the future. How is that? I'll explain that in using an example. Okay. Yeah. All right. So let me use this example. Say fuel consumption. Let me use that as an example. I have a data set of different cars. Yes. And there are 4 consumptions and the different trips that they are taking. Yeah, let me use that. Now, a data scientist can be able to tell you that if you follow these paths by 3 p.m., you should consume so amount of fuel. Yes, a data analyst cannot tell you that. A data analyst will just tell you that 3 p.m. so days ago, so car consumed so amount of fuel. Hello, are we there? We actually we need to spend some time to actually differentiate. The differences between them is actually is large, but it's not easy. It's not as easy to get, especially for persons who are new into the field. Now, a data scientist can make predictions. They can tell you that with this data that you have, what is the probability of this data that you don't have in the future? Now you don't have it. So data scientists can help you look into the future using your data sets. All right. Now, another thing a data scientist can do is a data scientist can automate your process. You are not expecting a data analyst to automate processes. A data analyst help you understand the businesses, your data, but a data scientist primarily helps you make predictions and automate your tasks. So you see why we look at it that a data scientist goes one step ahead, one step after a data analyst. So you have a data analyst and you have a data scientist just one step there. Now the kind of analysis you do now as a data scientist and as a data analyst is different, it's subtle. I don't know if I should explain that here, but for persons who have slight background in this, they might be able to, they would get it. But if you don't have a background, you can still listen though. The kind of analysis a data analyst does is, a data analyst use business that like analysis like, okay, what is the income that we can get from advertising in this role, advertising in this environment? Yeah, what are we expecting in 2024? If we implement this policy, what is the likely return that is going to give us? If we decide to change our product to blue, what is the likelihood that people would accept blue more than red? There's data sets for that. Are we there? Now, the kind of analysis a data scientist does is a data scientist does the analysis that will allow it to train models to make predictions. Now, most times you are not basically concerned with how to answering those kind of questions. You are concerned with, will this data set work for prediction? Would this data set work in my machine learning model? How do I make this data set to be compliant with my machine learning models? How do I make machines to learn from this data set? That's the primary analysis as a data scientist. See the subtle differences between the both of them. You are still analyzing though, but the analysis now is towards training a machine instead of analyzing for people. Data analysts will analyze for people to understand. A data scientist will analyze for a machine. Yeah, you want to use that data to train a machine that would make predictions and automate. Don't worry if you still didn't get that though. Yeah. So, but what you should understand though, as the major difference between both of them is data analysis, data understanding data, primary objective. Data scientist, understanding the data, making predictions and automating, primary objectives. So what are the tools that a data scientist use? Now, a data scientist will use those tools that a data analyst use. Yes, a data scientist use those tools as well. Now, in addition now, Python is no longer an option for a data scientist. You know, for a data analyst, you can have it as an option. But for a data scientist, Python is no longer an option now. Python is a requirement. Sorry, Python or R is a requirement now. Because your major field of your major responsibility is now coming towards prediction and automation. So you actually need Python to function in that landscape. And what does Python allow you to do here now? So what does Python allow you to do here? Now, if I'm looking at automation now, I don't want to be present every time. I just want to design something that will just continue acting by itself. Yes. So, like the example of automation that I give, if requests or transaction levels go beyond this stage, please do this. That's one level of automation. I don't want to be waking 12 a.m. to now be looking at those. So you need something that will be able to do those tasks automatically. So you need a programming language for that. You know, a programming language is a way of instructing machines to carry out your instructions. Yes. So when it comes to data science now, we are looking towards training models, training agents that can act on their own. Yes. And you always need, so Python is one of that programming languages that we can use to make that possible. So you use Python to train a model, use it to deploy your models. Are we there? Another skill of another major tool of a data scientist, I really don't know whether I should add that as a tool, but I'll put it as a tool. It's still perceivable as a tool. So it's machine learning. That's still have time. So machine learning. Now, what is machine learning? Machine learning is that field of data science, that part of data science that allows you to train machines. Now, the traditional way people do it before in software is this. Traditional way. They will tell the machine something like this. If transaction in November is greater than 50, do this. Are we there? Okay, I think this example would go well, will go better. Let's say we want to create a product that will detect fraud. There are fraudulent transactions now. Now, one way I can do it before, one way I would do it in traditional software engineering is this. I will look at the data set, probably bring up a data analyst and tell the data analyst, please analyze this data set, figure out those transactions that are fraud on this data set. So an analyst can look at it and say, okay, all the fraudulent transactions are greater than they are greater than 1,000. If you have a transaction greater than 1 million, and the reason for that transaction is say leisure, then it's a fraudulent transaction. Now I have that idea now that okay, if somebody is making a transaction of above 1,000 and the reason is leisure, it's likely to be fraudulent transaction. Traditionally, before, what I would do is I would just go into a program. I will write a program that will say, if transaction is this, do this. If transaction is this, do this. I'll do those before. Now, it will work in some cases, like this one, where it is obvious. There are cases where it will not work. Very complex cases where we cannot easily identify which of those transactions are fraudulent. Are we there? Now, in these cases, I would want to just I want to give my computer the data set. Say, hey, take the data set. This one is a fraudulent transaction. This one is not a fraudulent transaction. This is a fraudulent transaction. This is not a fraudulent transaction. I will label it. When I give it to my model, my machine, the machine is able to learn the pattern. It will look at all the things together, even pattern that I'm not able to identify. That's the power of machine learning. I'm not able to identify it as a person. Your machine can identify those patterns, those slight patterns that identify fraudulent transactions. To identify it. So that is the field of machine learning. It is that field where you pick data, give it to a machine, and the machine is able to identify, to differentiate. Okay, it's length. This one is this. This one is not this. This is this. This is not this. And it's able to make decisions based on what it has learned. That's where the name comes from, machine learning. It is just more like you giving data to a machine and asking it to learn. So it is one field, one skill in data science. If you are a data scientist, you must have a skill in machine learning. You must be able to train different models to perform different tasks. Now, I said it before, other data analyst tools, yeah? Now, other tools of a data scientist, deep learning. Deep learning. Some of us would see machine learning, then would see deep learning. I wouldn't go into the details of this, but the major difference between both of them is that machine learning works with structured data. Deep learning works with very unstructured data. Now, what I've been saying since is data set like OPA's data. They have them in tables. OPA would have their data set in tables, like the way you have them in Excel. It would be like that. Now, there are some data that are not in that format. For example, image, pictures. Pictures are not like that, and pictures are data sets too. So for you to work with pictures, most likely you work with deep learning. What about voice? You have voice data. Some people have voice data. Yes, they have customer calls. You want to analyze customer calls. You want to, yes, it's a form of data set too. For you to work with that, you need deep learning. Videos, you need deep learning. So when you come to unstructured data, those data that is not available in tabular format, you are most likely going to work with deep learning. Now, what are the major skills in data science as a data scientist? Why? Yes, the skills of data analyst applies here too. Communication skills. Communication skills. Now, I read it somewhere where somebody mentioned that if you have technical skills as a data scientist, it gives you the job. But skills, your soft skills like communication skills, makes you grow quicker. Now, why is that? If you cannot communicate, nobody will trust your model. Ban. If you cannot communicate, nobody will trust your model. That's just it. Now, and don't forget that you are creating something that is supposed to be used for automation. Nobody is now, is still better as a data scientist, as a data analyst, because people are still there to monitor these things. At some point, people don't monitor, people will not monitor your model like monitors, sit with it and monitor it, because they believe that we have a system that is doing that. Now, for them to now put in your system to be interfacing with people, they need to trust whatever it is that you have done. And for us to accept whatever work that you are doing, you have to communicate that you have done something. In fact, data science courses should do presentations. If you have not done presentations as a data scientist, I think your skill set is complete. As a data scientist, you need communication skills. Data engineers, the third. Data engineers. So I've mentioned a data analyst, I mentioned a data scientist. We get the difference between both of them. Data analyst, data understanding, data scientist, data understanding, prediction, automation. Now, who is now a data engineer and what do they do in this setup? Why are data engineers important here? I think 2 years ago, you won't discuss these two of them and you discuss data engineers in the same thing. They are not, their popularity are not the same. Because data science came from out of the blue, and every company wants a data scientist. Like this company just come, hires data scientists quick. But the next years following it, they find out that they are just chasing thin air. Whatever it is that you are doing as a data scientist or a data analyst is driven by data. And you see that data feed beyond databases. It's actually a lot more complex than databases alone. Now, when you have a database, fine. That is actually a structured data, then you can. But in some of the cases, especially for these big companies who need data scientists and data, their data are not as organized as you think they are. They are not as organized. So they will need a data engineer to actually define data infrastructures for them. In fact, some of these companies don't even have very structured. Yes, but they want data scientists. So a data scientist is actually very useless if you don't have well-defined data, and data engineers allows data engineering. Data engineers does that. An example, I would give us an example. Yes. We want to work with geometric data. We want to work with geometric data now. Geometric data has those spatial data, longitude, latitude, and co like that. Now, me as a data scientist, my skill set doesn't go into collecting data. My skill set doesn't go into that. What me I want as a data scientist is actually give me data. Yes, give me data. Now, if that data set is available in a database, then fine. Then I can actually use SQL to interact with that data. But there are some of those databases that are not available in a database. Yes, for example, geographic data now might not be available in a database. Say you want to collect data set of all the hotels in Nigeria. You might not have that data set in a database. Are we there? Now you need data engineers to define infrastructures. How is it that we are going to collect that data set? Where are those data sets entering? If we need to collect this data set again in the future, we still need to redefine these things. So they have that distance to define pipeline. They have the skill set to define pipelines. In fact, major role, they automate this data collection. Are we there? So data engineers, their primary responsibility is collect this data sets in a format that is useful for the data analyst, data scientist, and they define the structures to collect those data. Easy. Now, what are their major tools? They use SQL because they can work with databases. Now, they use Spark, Kafka, AWS, Azure Factory. Majorly, most of these ones work with big data. Yes, when these data sets are big. There are some data sets that people work on Excel with. Sure. I think Excel, without the setting, you work on how many million rows? I cannot remember, but those millions though. But now, what are the other roles that you can hear from the data landscape? We have actually heard of data analysts, we have of data scientists, we've heard of data engineer. Now, what are the other roles that you can hear? You can hear people say, I'm a machine learning engineer. Okay. Now, we actually know what machine learning actually is. Machine learning is a soft skill in data science. If you're a data scientist, you should have machine. So automatically, I think you should qualify for a machine learning engineer. But some people always choose to have that title, machine learning engineer instead. Now, big data analyst. Big data analyst is similar to your data analyst, but this time they just want to add it that I don't work with only small data sets, so like the one you have in your traditional databases, small ones. I can as well have the skill set to work with very large data sets, trillions, terabytes of data sets. So that's where the title comes from, big data analyst. Now we have business intelligence analyst. Same with data analyst, but note now that many of these are stepping out. They are stepping out from data analyst or data scientist. Now the need is because that thing is that those domains are actually large. For somebody for a business that is in health, in the healthcare sector, would need specialty in health. Yes, you need health background. Should I say background? You need that skill, that knowledge, that health domain knowledge if you want to function as a data analyst in the healthcare. You know, healthcare should require data analysts. Yes? They want to monitor their patients, what diseases are common, what is the common diseases. Now, it is quite different from the data analyst that is functioning in OP. What OP is interested in is wants to know the number of transactions. So in this part now, it is actually so large for you to tell a data analyst to pick up skills in the health informatics domain, to pick up skills in the e-commerce domain, to pick up skills in the geometric domain, like environment analyst now. So now, because those places require specialized skill, now they now choose to bring them out of themselves. They are still data analysts. Big data analyst is a data analyst, business intelligence analyst is a data analyst, health informatics analyst is a data analyst. They are all data analysts. But because of their domain, the kind of domain knowledge they require now, they now step them outside. So if you are functioning in e-commerce, you should probably be business intelligence analyst. If you are functioning in the healthcare sector, you should be a health informatics. If you are functioning in the environment sector, you should be an environment you should be an environment analyst. So why data science? Quickly, I'll rush over this one quickly. So why should you pick data science? So there's three major reasons why you should pick data science. One is because it's a field that is not likely to die soon. Okay, so it's a field that is not likely to die soon. You know, there are some domains that you just look at it and you look at their prospects. I just know that maximum in the next 5 years. I don't see anybody here again. Yes. So I don't think that is applying to data science. Data science is actually the bedrock of modern inventions. Modern invention, mention them and I will tell you where data science has played a role. And even if data science will just play a role, mention them. And the most transformative technologies of this centuries has data as their backbone. For example, you mentioned things like ChatGPT, which is changing the dynamics now. ChatGPT has data as the bedrock. But you need, how do you do it without data scientists? It is still improving. It is still coming up. Now they are trying to include data science into almost every sector. Mention it, sustainability sector, data science is running there. Production, manufacturing, data science is running there. So almost everything. Robotics, yes. Robot, every intelligence I see a robot executes. Every intelligence, I'll mention it. As long as it's intelligence, you cannot mention intelligence without mentioning data. And the 21st century is actually driven by intelligence. Yes, we are not in that era that is mechanical anymore. Yeah, I think there's still development in the mechanical sector, but not as what we have going on in the data science spectrum now. So if you are looking at data science, you should be looking at it that, okay, it is not a sector that is likely to die any moment soon. People must definitely collect more and more data. Yes, more. If you think we are collecting terabytes of data now, imagine the amount of data we are going to be collecting in 5-10 years. Yeah, that's how important data science will be. You need persons who are skilled in this data field to handle that for you. Now, okay. All right. Now down to the final before I hang up. So our data science course at Vinicom Tech Hub, we actually have a data science course. And what are the content of our data science course? So we have Python for data science, where we take you through Python. I will introduce you to all the parts of Python that you require to work in the data science landscape. Yes, you might have had it, you might know some Python before. In fact, it's encouraging for you to know Python before. So please, if you are considering data science whatsoever, we are serving now. I think one of the investments that you can do now is to start picking up Python. Please just watch Python, like start picking it. It's large. We know, like it's used for it's a multi-purpose language. Aside data science, you use it for different things. You use it for web development, you use it for desktop development and co. So while picking it up with slides, you can see it, you can see them doing things that are not related to data science at all, and be doing some other things. But it's still vital for you to pick it up. Now, when you pick up data science, when you pick up Python, you come towards this place, then we help you narrow your Python skills towards the data science landscape. Put you through that direction. What are the things, what are those things in Python that you know that we use in data science? All right, another thing we learn is Power BI. Yes, so we'll put you through exploratory data analysis using Power BI. You explore data, can make decisions with data, you answer questions with data, you process data, you process data sets with Power BI. Now our curriculum goes into Matplotlib, Seaborn, NumPy. These are Python libraries that we use in data science, like the Matplotlib now. We use it to plot visuals. Seaborn, same. NumPy and SQL use them to munch data. NumPy is great for calculation. Yes, you want to run mathematical calculations. NumPy is a great tool for those. Now, sklearn for machine learning is the primary tool that we use for machine learning here. Now we dive deep into deep learning. We spend some amount of time in machine learning. Spend quite a great deal of time here because it's one of the primary responsibilities of the data scientist. We help you create models, make predictions, yes, classify, make classifications, predictions, work with both natural language processing. So now we do not stop there. Many machine learning, many data science curriculum will stop. Yes, you can make machine learning models. You have them on your notebook and it's fun, and it stops there. Yes, but we go as far as to help you deploy these models. How do you now? Okay, I have an app that I am building now. I want to use your machine learning inside my app. How do we do that? So we help you deploy. We'll put you through deploying your machine learning models. Well, many of these models you see in your phone, the voice recognition system is a deep learning model. Autocomplete, this thing, many of them are machine learning models now. So you have applications like that, and somebody wants to actually deploy them beyond you just knowing that this works and it ends in your notebook. You can actually see them work in deployed state. Now, another key strength of our curriculum is everybody must have a presentation. You cannot receive your certificate here if you don't present. You have to defend. You do a final project. You have 1 month to create your final project, and you do a defense of it. Now, one thing that helps you to do is you're already building your profile while you are here, because at least before you complete the course, you must have worked on at least one project. You must have worked on at least one project. Then when you finish, you work on your own capstone project, beginning to complete, and you defend that project. So this will give you at least the kickstart. So this will give you the kickstarts for your career in data science. At least you have a portfolio. You have a portfolio to start with. After your classes here, then we have communities here as well. So we'll help you work on projects if you need us. And we also organize monthly seminars, I think. Yeah, monthly seminars to keep you on track. So at this juncture, I think I have done a good job. Let me applaud myself. I think I've done some job in the data landscape. This by now we should be able to distinguish between each of these sections.
Okay, hi. Good afternoon.
Yeah, good afternoon.
Yeah, so for data science course, yeah, it's a 6 month course, and the course fee is 210K. Yeah, so we are giving corp members a 5% discount. And we are also starting fully in March. So if you need to enroll, you can always reach out to us via WhatsApp or email.
One major framework. So we recommend Vue, right? Vue is one thing that Vue has above the other frameworks like React and Angular. Angular is another framework. I don't really like Angular. That's why I didn't type it. All right. So, but Vue has an edge above the other frameworks because you will find that Vue has two-dimensional data communication or data flow. So you can easily send data from your backend to a front-end component in Vue, and also from a front-end component to a backend component with Vue. But in React only has one-way data flow from a parent component to a child component, whereas Vue is designed to have a multi-way or two-way data flow. So that's why Vue is more, to me, some people might feel otherwise, but to me, I feel Vue is more suited when you want to build full stack applications. On the backend side of things, we have technologies like C#. C# is actually a programming language. There's also Python, of course. There's also Python programming language. There's also PHP programming language. There's Java as well. But all these are programming languages, right? They are programming languages that backend developers use for their trade, for their work. C# is top because that is our specialty at Vinicom Solutions. But not just that, C# is a very, very robust programming language. It's very robust. You can use C# for game development. You can use it for very large-scale projects, right? Very large-scale projects. And it is relatively very, very, very fast. You can also use it for mobile development. So it's a very versatile and robust technology, C#. And just like you have frameworks in the front-end side of things, you also have frameworks in the backend. And for C#, I think there's a family of .NET frameworks or .NET technologies that allow you to right out of the box to handle some of the very common tasks that you would need to always do as a developer, as a backend developer. We'll talk some more, we'll have time about frameworks, what they are and why they are important. All right. So basically, this is your landscape as a full stack developer. You need to understand your front-end technologies very well. You need to understand your back-end technologies very well. All right. So let's look at let's talk a little bit more about front-end developer. So a front-end developer does primarily what we call client-side scripting. So you are writing code that will run on the browser. So what are the things that you need to know? All right. So as if we already said HTML, CS, and JavaScript are foundational. But as a front-end developer, your primary assignments will be making your web pages or your website look exactly as designed, right? Remember, we're talking development now. We're not talking design. There's a difference. All right. So your responsibility as a front-end developer is to ensure that you are scripting exactly to the design. So your designer has created a website, has designed a website. Your responsibility as a front-end developer is to script it in such a way that when it is displayed or rendered on the browser, it looks exactly the way the design was created. That is responsibility. So to do that, you're going to need to know how to use your HTML very well, your CSS, which is cascading style sheets, very well, your JavaScript very well. Then also importantly, understanding routing, what we call routing. All right. So routing, for time, I don't want to like script everything, but those of you who are on our community, we are going to share a more detailed slide so you get to understand it. But even better, just enroll for the course, and then you get to experience most of the things we're talking about. So you have to understand routing. You have to understand things like file structures. You need to understand file structuring very well. You need to understand your way around using paths very well and endpoints very well. You also need to understand web technology, the general scope of how the web works. You need to have a very good understanding about that, because many a time as a front-end developer, you have to be getting data from what a back-end developer has supplied to you. So you need to understand how to grab that data and display that data that you have gotten from the backend on your browser in a way that meets and matches what the design is. So that is what is called client-side scripting. Client-side scripting has to do with everything, all the code you are writing to make your designs appear on a browser. Now, what of the backend? The backend developer deals with server-side scripting. On the server-side scripting, like I said earlier, you're writing code that runs on a server. What is a server? I said a lot about the client. The client is basically the browser, but what is a server? You've heard of server. A lot of you maybe probably have heard of server. The server came down when the elections were going on. There were a lot of things about glitches, about servers and all of that. But what is a server? Now, a server is actually just a computer, right? A server is a computer, all right? But it's designed to perform a particular kind of role. A server is a computer that is designed to accept requests, process the requests, and send back responses. I'll repeat that because it bears remembering. A server is a computer that is designed primarily to accept requests, process those requests, and send back responses. Very important. Those are the three major responsibilities that a server carries out. It receives requests. It carries out different kinds of operations on that request. Some of those operations will be logical operations. Some are computational operations. Some are data kinds of operations. And then ultimately, based on the request, it sends back a response. So that is basically what a server is. So technically speaking, your laptop can also behave like a server if you can script it or configure it to accept requests, process those requests, and what? Send back responses. All right. So basically, that is what a server is. Any computer that is able to perform these three things can act as a server. Of course, this is putting it very simply. In actual sense, server does a lot, way much more. And these simple things, these simple steps that I just mentioned, request, processing, and response, sometimes those requests could be in the millions, right? So imagine people sending millions of requests to a particular server. So then you begin to understand that your laptop might not just be adequate to be a server at some point. Do you understand? So, but basically have that at the back of your mind. Now, I said some things. I said the server accepts requests, processes, and responds. But where are the requests coming from? Where does it get the request? That is where the client side, comes into the game. The requests that come to a server come from a client. That is typically like a browser. So the browser, which is a client side, which is in the domain of the front-end developer, typically they will be sending requests to the server side, which is in the domain of the back-end developer, right? So a back-end developer primarily writes code or scripts, right? Code or scripts or programs that enable the requests that will be coming from the browser or the client to be responded to or processed or acted upon, perform certain logic, and then send back responses. So you as a backend developer or the backend developer will be responsible for writing all that logic, all that code, all that program that will correctly interpret the request, handle them, process them, and then do what the request asks to do and send back a response. So basically, that's what a backend developer does. So if you look at all of these, it's a full stack developer has a lot of work to do. So imagine a full stack developer designs and scripts, not design, develops the front end side of things. So it's invariably scripting or programming all the requests, the possible requests that are going to be sent to a server, and he comes back, runs back to the server side of things, and then scripts the logic to handle all of that. So the advantage of being a full stack developer is that since you are the person who has already scripted the request, it is easier for you to understand the nature of the request and then script your backend or your server side to adequately, accurately, and precisely interpret and process all those requests on the back on the backend on the server side. All right. So let's move. I hope I'm being clear. Of course, there'll be time for questions and everything. I'm speaking quite fast because I'm on a time here. So I apologize if I'm speaking over your heads. All right. So let's see the learning curve or the learning path. So basically, in web development as a whole, the advice usually would be that if you want to do full stack development, you start from the front end, right? You start from the front end, and then as you get proficient in the front end side of things, then you move into the back end side of things. Of course, it doesn't mean that it has to always be that way. I know a lot of people who start learning backend and then venture to front end. I think the person who spoke earlier talked about him being a front end developer. Now he's acting as a backend. So it actually depends a lot about your passion, your commitment to learning, and all of that. So, but basically, traditionally, we recommend start with front end, via through backend, and then you proceed from there. But the overall path of a full stack developer culminates into becoming a team manager, right? A team manager, because it's rare for you to have companies. There are companies who actually advertise for full stack developer roles, but usually what you find is that as a full stack developer, you are like a team leader. You are a developer's team leader. Since you understand the full scope of the whole software development process, you have a great understanding, a broader understanding of it. Most times, full stack developers are employed at the senior level, all right? Not to say that you can't employ them as interns, of course, or junior devs, no. But usually, even if you're a full stack developer and you come to a company, they will actually want you to function in one of the roles, either as a front-end person or a back-end person at first. Then as you become more proficient, you become a senior, ultimately full stack developers end up becoming team leads, or they begin to manage the broad spectrum of the web development process. All right. So in between other skills that full stack developers tend to have is version control system skills using Git and GitHub, Bitbucket, and the likes, GitLab. And then also sometimes they also, as a plus, have understanding of DevOps. DevOps have to do with all the processes that involve deploying your code, the code that you've developed on your computer, to a server, all right, or to a hosting platform where that is, because there are different environments. You know, as a developer, you understand that there are different environments in which your code runs. There's a local environment, which is typically called the development environment. That's when you are building your software. Nobody knows what you are doing. It's only you and your computer that know what you're doing. So that is typically called the development environment. You are doing your thing on your VS Code or whatever editor you are using. Nobody knows it. But when you're done doing that, you've tested it on your local computer and you realize that, oh, this thing is good to go. You want the world to see it. Voila, that's when DevOps swings in. So DevOps is responsible for handling all the operations that lead to moving your code from one environment, typically development environment, to what is called staging and then eventually production environment. In the production environment, that's where it is available for people all over the world to hit www.mywebsite.com, and voila, your site is viewed and people can see it. So DevOps is kind of like a butter in the bread roll. So it's what makes it smooth for deploying whatever the developers have done to a computer, a hosting environment where people can actually access that. So typically, a full stack developer tends to be a jack of all trades kind of person, all right? We advise that he be a master of all, not a master of none. But generally, that's the story of full stack development, all right? So next steps regarding your interest in this, I just want to say something. Our industry worldwide is generally moving at a very, very fast pace, right? So a lot of things are changing. But one thing that remains constant is the need for scaling. Everybody wants to do everything fast, quickly, and get as many people as possible to know that this is what they are doing. People are generating content value at very high speeds. Now, that necessitates that the job role of a developer, front-end, back-end, full stack, it's not going to go out of the market anytime soon. In fact, the demand is crazy right now. You just need to go to the platforms like Facebook, go to LinkedIn, and you need to see how many times they're advertising for full stack developers, front-end developers, back-end developers, and all of that. So the demand is high. It's a skill set that I'll recommend for anybody who wants to buy into the tech space. That if it's something you really want to do, this is the time to get on the bandwagon, because the way the world works, the time is going to come when things are going to change drastically. So you don't want to join the boat when the ship has sailed. So I'll advise you guys to really, really make the point of making the decision to officially enroll and get this skill set, because the next era is going to belong to the people who join the tech space early. All right. So I'm going to stop right here. Thank you very much for listening. And then I will see if there are questions that I can answer. Thank you.